second. So everybody, if I said to you, add these two fractions, what's the first step when adding fractions? Getting a common denominator. You're right, okay? So you would say, okay, you're just still watching, you don't need to be taking notes here. So to combine this into one fraction, you'd say I need a common denominator. So this denominator is x minus 1, this one's 2x plus 1. So this one would need a 2x plus 1. If you do that to the bottom, you've got to do it to the top. And then this one needs an x minus 1. If you do it to the bottom, you've got to do it to the top. Now the next step is to distribute in your numerator and combine like terms in the numerator. Agree? So what I have right now is this. I have a 2x plus 1 all over the common denominator of 2x plus 1, x minus 1. Then I have plus, distributing my 1 in, x minus 1 all over 2x plus 1 and x minus 1. Now the point of that is so that when we get a common denominator, we can combine the numerator, correct? So now we can write this as one fraction. We would just combine like terms in our numerator. So 2x plus 1x is 3x. Do you agree? Positive 1 plus negative 1 is gone, right? And that's all over the common denominator of 2x plus 1 times x minus 1. That's our answer. Now what a partial fraction is that exact process, but backwards. What you're going to be given is this is the starting point, and they're going to ask you to, it's called partial fractions. It's saying split this up into separate fractions, two separate fractions. That would be an equivalent true statement. So that's just working backwards. So now notice, if we have this denominator and this denominator split apart, each of them will have one of the denominators, right? Because then we get a common denominator. So it's once again just doing this process backwards, which it just takes quite a bit of algebra to get it correct. Does that make sense, everybody? Okay, cool. All right, because it's not going to be just any old thing. Like, these had to be ones for this to combine like terms and get a 3x on top. There was no other option that would have worked with these specific denominators. So it's actually, I really think this is super fun stuff. All right, so here's our first, one more thing. I'm just pointing something out so that when we get to this point in the partial fractions step, you're not like, what the heck are you talking about? Isn't 5x squared plus 7x minus 1, isn't the coefficients 5 for x squared? The coefficient for x is 7, and the constant coefficient's negative 1. Do you agree? So if I gave you something of this form right here, and I said, if we have a plus b plus c times x squared plus c minus d times x minus 4a plus b, if I said to you, given this, what would a plus b plus c be? Well, line them up. Isn't 5x squared going to line up with our a plus b plus c must be 5, true? If I asked you just kind of to match these up. So I would be able to say a plus b plus c needs to equal 5 for this to look like the above. So then isn't the 7x lining up with this? So what would c minus d need to equal? 7. And then right here's our constant, because notice there's no x's. So our constant's negative 1. That would match up with this. So it would be true to say that negative 4a plus b would equal negative 1. That's going to be our final step in our partial fraction, so I just want to show you where it comes from. It's just lining things up and matching up what the true statement would be. We wanted a plus b plus c to be 5. We want c minus d to be 7. And we need negative 1 to be our constant, which was negative 4a plus b. Okay, cool. Okay, here's called what's case number 1. Start taking notes. So there's going to be 3 separate cases we just have to take into consideration. The math works out the same. It's just the starting point is a teeny bit different. So with case number 1, when we have denominators that have linear factors, now distinct means there's just one of them. So distinct linear factors of degree 1 and no multiplicities. So that means there's only one linear factor with no multiplicity other than 1. Do you guys see how there's only one of each of these factors? When this happens, you're going to split it up as such. This is something you're going to kind of have to just kind of try to take notes on the best you can and kind of memorize the process here. So what we're going to do is we know instead we're working backwards. We're saying, what can we split this up as? It's 2 separate things. Now, why do I say 2 separate things? Because look, there's 2 denominators here. There's 2 factors in our denominator. So we don't know what's on top yet. That's going to make this work. So we're going to start out with just saying we don't know what's on top over x minus 1, but we've got to add that to we don't know what's on top, so b over x plus 4. We don't know top. It's going to get a common denominator to combine to be x. Does everyone agree? So that we want, in the end, to equal x over x minus 1 times x plus 4. That is what we want it to be. Agreed? They need to be equal. Yes, we're just now working backwards. We're splitting this up. So we've got to go through now, what we're doing is we're now going to find the a and the b that will make this a true statement. So let's go ahead and keep our algebra nice and pretty. So your next step in the process here is to times up by this denominator here. So we're going to times, technically guys, we're timesing both sides by x minus 1 and x plus 4, but won't it divide out over here? So I always am going to say just cross multiply, but we're not going to multiply this side over. So we're going to take this denominator and we're going to times it to technically both sides, but timesing it to this side. Now when you times it, don't you have to times each piece by it? Alright, so right here we're going to have times by x minus 1 times by x plus 4. Now this is also getting times by x minus 1 times x plus 4. Now I'm going to show it this one and only time. Technically we just times everything by x minus 1 times x plus 4. Because now we have not changed the problem, have we? No, we've done it to both sides of the equation. Alright, so now let's write out what this would simplify to be in each piece. So let's look at this first section here. What's going to divide out in this first section? Yep, so let's divide out our x minus 1s. And left over in this first section would be an a and x plus 4 being multiplied, right? This is all multiplication. Okay, let's move on to the second piece here. We have a plus sign, so plus. Now my x plus 4s, aren't they going to divide out? So now in this section I have a b, then I have times x minus 1. Notice I cross things out so I don't miss anything. And that needs to equal, well, don't these divide out? So that needs to, in the end, it needs to equal x. Okay. Everybody good mentally of what we just did? Okay. Next step is to then distribute, actually multiply this out. Now, we're going to leave this side alone, leaving this side alone. We're going to just focus on this side and start actually multiplying this out. So this would be ax plus 4a. Moving on, positive b times x, so plus bx. Positive b times negative 1, so minus b. And in the end, we want it to equal x. So now what you're going to do is you're going to reorder things that are like by each other. Like terms we want to put by each other. So all x's want to be near x's. All constants want to be with constants. So let's reorder it. Why can we reorder addition? Because 2 plus 3 is no different than 3 plus 2. You can reorder things. So I'm going to rewrite this so all my x's are by each other. So I have ax, I'm going to cross it out, plus bx, so I don't miss anything. Reordering it. Then my constants are plus 4a, and then minus b. And that, in the end, needs to equal x. Notice I haven't done anything with the x, right? This is what we're trying to get it to equal. Alright, so now what we can do is, notice, right now, we have, in these two terms, don't we have an x? So it would be okay if we factored out an x, because factored form and standard form are equal. So what we're going to do is we want to factor out an x, everybody. So pull out an x, so then divide by x, and left would be a plus b, right? You've just rewritten that in a different form. Now right here, nothing is in common, do you agree? So let's just write that. We have plus 4a minus b, and that all right there is our constant. Now we want this to equal the other side of, technically guys, isn't x technically, if I was going to start from the highest degree counting down, isn't x 1x plus 0 technically? This was 1x plus 0 technically, right? So let's now match up what matches up where. Meaning, what needs to be in front of an x in our true statement? 1. Well, what's in front of x here? A plus b. Isn't a plus b in front of x? It's behind x. Same thing as in front, right? Isn't, if I reordered this as a plus b times x, isn't it the same thing as that? So once again, what do we want it to be? 1x plus 0, don't we? So doesn't a plus b match up with 1? That was what we just looked at a few seconds ago. That's what we want it to be, is this side. So my true statement would be our a plus b needs to equal 1, because that's what's in front of x. A plus b was what's in front of x. 1 needs to be in front of x. Right. So now our constant is a minus b. What do we need it to be? We're trying to get it to be this side. 0. So our second true statement is 4a minus b needs to equal 0 to make this work to be the correct right side. And now what we have now is a system of equations that we would solve. This is a system of equations with two variables. So should we use substitution or elimination? Elimination, because look, if we add straight down, won't the b's cancel out? Okay, so now we're just solving a system of equations. So I'd say let's eliminate b, add straight down. 1a plus 4a is, so we have 5a, my b's are gone. 5a equals 1. Solving for a, divide by 5. So the a in our equation was 1/5, everyone. Okay, I'm going to circle that for now. That's not our official final answer, but that is part of our final answer. And now we got to go find b. So let's go plug it into one of these to get a b value. So let's just do the top. So we have 1/5 plus b needs to equal 1. Plugging it into the top equation, now solve for b. So I'd subtract 1/5. So b is equal to 4/5. Well, there we go. We can now use that to write in our final answer. So let's go back. What answer were we trying to get? Weren't we trying to take this original problem and split it up as this? So our final answer would be our a value over x minus 1. Sorry, I'm going to get myself some room right. It was a over x minus 1, so what was a? 1/5. So our answer is 1/5 over x minus 1 plus, what was b? 4/5 over x plus 4. That mathematically should equal the x over x minus 1 times x plus 4. That should equal this. So that's your answer. That's now splitting it apart. If you were to get a common denominator and combine like terms, you would end up with x over x minus 1 times x plus 4. So does everybody see? We just went through, we split it up, and then we went through and used math to solve. Yeah. No, that's my next point. So this is just not an answer you would see written in the back of a book. Because why? It's fractions over fractions. And they expect you to know, when you have fractions over fractions, that it's not an appropriate way to leave an answer. Isn't it true that dividing fractions, easy as pie, flip the second, multiply? Let's make sure we flip this correctly. Isn't this x minus 1 over 1 technically? X plus 4 over 1. So when we flip and multiply, we're going to have a 1 on top and x minus 1 on bottom. When we times, we're going to have a 1 on top and an x plus 4 on bottom. So when you check your answer in the back of the book, if you ever have fractions on fractions, you're going to want to write it in the most simplified form. So technically our final answer is 1 over 5 times x minus 1 plus 4, right? 4 times 1 over 5 times x plus 4. Do you guys want me to hurry and get a common denominator, combine like terms, and then show you that it really does end up here, or do you believe me? Yes. No, because that was the changed equation, right? We times it up by that. So we would want, this is like what we're actually trying to find right here, is just the original split apart point. Do you guys get what we did there? If I was to get a common denominator, combine like terms, I would end up at x over x minus 1 times x plus 4. My 5s would end up dividing out. Because see right now how there's a 5 in it? Okay, cool. All right, let's do another one. Okay, here we go. So notice it says find the partial fraction decomposition. That means split this up. Now the question is, how many split ups are we going to have? Well, we don't know until we factor out our denominator, because before we had it all together, it used to be least common denominator. Now so we would need to first factor out our denominator. So what would we pull out from the get-go? An x. So then we would have x squared plus 2x minus 3. We would need to keep factoring it if possible. Well, multiplies to be negative 3 and adds up to be positive 2. 1 times 3, negative 1. So I'm going to rewrite what I have. My original problem is 7x minus 3, and that's all over x times x minus 1 times x plus 3. I've just written the same thing in factored form, right? Now our answer is, if you were to split this up, what could we split this up to be? Well, isn't there 1, 2, 3 pieces in the denominator? So before it was all put together, it was split apart in 3 ways. So we would have a over, waiting, x plus b over x minus 1, because we don't know what was on top of that, right? And then plus c over x plus 3. And when we got a common denominator, it came out to equal this. We're just working backwards. Now, once again, notice this is case number 1, because all of these are linear factors, and they all have multiplicity of just 1. If we have multiplicity of 2, we've got to do something a smidge different to start out. Okay, what was my next step now? Yep, we're trying to actually find the numerators, aren't we? So we're going to times up by this denominator, we're going to times to both sides. Now we know it's actually going to divide out over here, so I'm not going to write that. So we're going to times up, so we got to times each piece by x, x minus 1, and x plus 3. So this is also times by x, x minus 1, x plus 3. C is also times by x, x minus 1, x plus 3. So since we times that over to the other side, it's gone now. Keeping your work nice and pretty, being super careful. You make one error here, and the rest is wrong, and it's going to be sad, like very sad. So we got to be so careful. So we got to all focus. Okay, what would then the first piece end up being? Don't my x's divide out. So left in my first piece is a times x minus 1, x plus 3. Now I can cross out that entire thing. I've taken care of it. Now I want my x minus 1's divide out. So I have a plus sign, then I have a b and an x plus 3. Plus sign. My x plus 3's will divide out here. So I have a cx and a x minus 1. And in the end, we want this to equal 7x minus 3. So leave that alone now for a while. Next step is to distribute, right? So let's start distributing. Now very carefully, when we're multiplying 3 things, how I would do it is multiply these 2 together, combine like terms, and then distribute in a. So let's do that very carefully. X times x is x squared, right? X times positive 3 is plus 3x. Negative 1 times x is negative x. Negative 1 times positive 3 is negative 3. Combine like terms. X squared plus 2x minus 3. And all that stuff needs to be times by a. So now let's distribute our a in. So wouldn't that be now ax squared plus 2ax minus 3a. Okay, so now I can go ahead and cross out all that stuff because I've now distributed that. Let's move on. Let's distribute out this one. Bx times x. So plus bx squared. Bx times 3 is plus 3bx. Now I've taken care of all my bx's. Cx times x plus cx squared. Cx times negative 1 is negative cx. And we need that in the end to equal 7x minus 3. So we ignore that side for now. So now we're going to reorder it so that all my x squareds are by each other, all my x's are by each other, all my constants are by each other. Don't wait for me to do it. It will take you longer to look at mine and then write it down. Just do it. Like put all the x's by each other, put all the x squareds by each other first, then put all the x's by each other. Just reorder this, but make sure you don't mess up on your signs. Put all your constants. So I cross things out so I don't miss anything. Okay, now that you've reordered it, shouldn't we then factor out the common thing in each piece, in each section? So in these three, I see an x squared. So I'm going to pull out an x squared. So then divide by x squared, divide by x squared, divide by x squared. So then left would be a plus b plus c. Okay, moving on. With this section here, don't you have an x in all of them? Okay, well, let's factor out a x then, a plus x. So we're pulling out plus x, positive x. So then left would be, look, divide by x, divide by x, divide by x. What would be left? 2a. Yep. Minus c. Good. Now with this, our constant, nothing in common. So minus 3a, I'm just going to write is my constant. Now don't we need that in the end to equal 7x minus 3? My coefficients are 7 and negative 3. All right, let's line it up. Was there any x squareds here? No, so technically, guys, we have 0x squareds plus 7x minus 3 is what we want in our numerator. Wasn't that the original problem technically? So let's line things up. We need there to be 0x squareds plus 7x's minus 3. Line up what the true statement is. What's with our x squared? 0 and a plus b plus c. So my true statement is a plus b plus c needs to equal 0. Alright, now doesn't in front of our x's is this and this. So my next true statement is our 2a plus our 3b minus our c needs to end up to be 7. And then my constant needs to line up with my constant. So isn't my true statement negative 3a equals negative 3? Alright, I'm going to put a box around that, and then I'd say now I've just got to solve the system of equations. Now notice this is a system of equations with 3 variables, so we can eliminate a variable. But isn't there a smarter way on this one? Can't I just solve for a right here, right now? Then let's do that. So solve for a right here, right now. So you divide both sides by negative 3. So a must equal 1. Okay, let's move on. Now look, let's go plug that into the top and middle, and then we can solve our system of equations. So then we have 1 plus b plus c needs to equal 0. And then down here we have 2 times 1, because a is 1. So 2 plus 3b minus c equals 7. When solving a system, don't we get it so that it's BC constant? BC constant. Variable, variable, constant. So I'm going to subtract 1 on the top. I'm going to rewrite this equation. Subtract 1, subtract 1. So isn't it true that b plus c equals negative 1? Rewritten that one. I'm going to get it to BC constant. So I'm going to subtract 2. So now also we know that 3b minus c needs to equal 5. Okay, let's solve by elimination, because look at, don't our c's just cancel out if we add straight down at this point? So we're just solving. So adding straight down, it looks like I'm going to get 4 b's equals 4. Therefore, we know b must equal 1. Divide both sides by 4. We know AB, we just need to find out C, so let's go plug it in and find out what C is. A, I'm going to do it to the top one. 1 was A, plus B was 1, and then plus C needs to equal 0. 2 plus C equals 0, therefore C equals -2. We now know A, B, and C, so now we know our answer. Let's go back and write in our final answer. So our final answer was A over X. A was 1, wasn't it? So this splits up into 1 over X plus, wasn't B 1? Plus 1 over X minus 1. And then plus, our C was? Yep, so I can write -2 or plus -2. It doesn't really matter. All over X plus 3. This and this are equal true statements. If you were to get a common denominator here and combine like terms, you would end up here if you did it correctly. Any questions? So that was fun. It's just about being careful. All right, should we do one more of that type? And then, okay, one more. This is the longest one, but how about I let you guys kind of work through each piece. I'll just check in with you. Try one by yourself, okay? I'm going to check in with you along the way. So, can anyone remember how to factor if you have 4 terms? Grouping. So let's at least factor the denominator together, just to make sure we don't start out on the wrong foot. So I pull out an x squared, left is x plus 2. I'd pull out a -1, wouldn't I? Then left is x plus 2. Our safe haven's the same, so we can pull out x plus 2. And that leaves me with x squared minus 1. Is that factored completely? No. What does that factor to be? Yep. X minus 1, x plus 1. So our true statement is this. 5x plus 7 over x plus 2, x minus 1, and then x plus 1. Now notice, once again, we have linear factors, none of them with multiple multiplicities. Alright, so you guys get started and tell me how we would start to set that up. And then I'm going to let you just roll with it for a second. Anyone want to share their true statement just to start out with? Okay. Okay, start going for it. in my, I just realized something in my notes. I had done just the factor of, I had written x plus 1 first, you know? Not that it won't matter in the end, but it was like not matching up with my work here. So I'm having to go back and just rewrite it correctly. In the end, it will all work out the same, but. Did you guys order yours in the same order as mine? You didn't do x plus 2, x minus 1, x plus 1? Well then, yeah, it's not going to match up with mine. So we'll just have to look at our answers in the end. I feel like at this point, though, when we combine like terms, that should be the same. Are you guys doing good out there? Remember, yours isn't going to match up with mine exactly if you didn't do the exact same order as me. You guys done? You found A, B, and C? Cool. What'd you get? I'm just going to compare it to mine. Like my final answer. What'd you get for A? So did I. What'd you get for B? Yep. And then C? Yes. Did you order yours different than mine? Up here? You ordered it the same as up here?
Yeah.
Cool. Because I did it different on my paper. It's the same answer. It should be, which makes sense. Cool. Video at this point, I'm going to eliminate personally A. The middle equation A is already eliminated. 3B plus C equals 5. I'm going to eliminate A, which this is the last time's lesson once again. So A plus B plus C equals 0. I'm going to put my bottom one in. Oh, 2B, not 2. I don't have mine lined up. So maybe I should reorder this. That's negative A plus 2b minus 2c equals 7. And then I'm adding straight down. My a's are gone. 2b minus c equals 7. Now I'm going to use these two to eliminate and to solve. Plus c equals 5. So adding straight down. You don't have to change anything here. 6b equals 12. Therefore, b equals 2. Perfect. So now I can solve for c. So I'll plug this in here. 3 times 2 plus c equals 5. 6 plus c equals 5. Therefore, c equals -1. I'll put 1 in here. I don't know what it is. Plus 2 plus -1 equals 0. So a must also equal -1. And there's our answer almost. We just got to put it in the right format. Okay. So your final answer would look as such. Now, once again, guys, if you think about it, so I have right now, my answer is -1 over over x plus 2. And then we have, on down here, and then we have plus b was 2, right? 2 over x minus 1 plus, and then c was -1 over x plus 1. Now, if your guys' denominators don't match up with mine, that's some of yours are probably out of order. They're not the same as mine, right? But if you think about it, once we get a common denominator, will the order matter of what goes on? Once we get a common denominator, does order matter? No. So you just got to check if your A, B, and C are correct, basically. Yeah. What order did you do? You did A over? Okay. I'm trying to. So you're just saying that like these are different, like this has a -1 and this has a 2. Trying to think. Hold on. Let me messed up somewhere. Okay, so what we've discovered is that you can have this stuff in different orders, but -1 has to be over x plus 2. Sorry, I'm saying this for the video. 2 has to be over x minus 1, and -1 has to be over x plus 1. But this can be reordered. So you could have -1 over x plus 2, plus -1 over x plus 1, plus 2 over x minus 1. But your top and bottoms have to be as such. Okay, so if not, you made an error. Let's just move on. Be more careful the next time, because we don't have time for you to redo it. Remember, it's really hard to figure out where your error is. All right, so here's case number 2. We just saw how to split it up with partial fractions if we have all linear factors of multiplicity 1. When there's multiple multiplicities, we actually have to do something a little different. So you're just going to have to pay attention and kind of memorize the process and write yourself some notes on how I split this up. The math ends up being the same in the end, but it's just the starting point of how we split this up has to be a little different. So notice we have right here, this is case number 2, when we have denominators that have factors that are linear but have multiple multiplicities. So isn't this x minus 1 to the 3rd power? Multiplicity of 3. Linear but multiplicity of 3. So how we have to split this one up is as such. So this one only has multiplicity of 1, so it's just like it was in the last examples. We have an a over x plus, now what we're going to do is we start with degree 1 and then count up to the multiplicity. So watch what I mean. So we're going to have a b over x minus 1 to the 1st. Then we're going to have plus c, counting up, x minus 1 squared, plus d over, counting up to the multiplicity, x minus 1 cubed. So you just start with 1 and count up to the multiplicity. We're not going to get into y. We don't have time to get into y right this minute. We are literally kind of short on time. So that's how you set these ones up. If they have multiple multiplicities, you have to start with degree 1 and count up to the multiplicity. So that needs to equal x squared plus 1 over x times x minus 1 cubed. But then that's the hardest part, setting it up right. Now let's do the math part behind it. So what would be my next step, just like we did in our other examples? Yep, times this denominator over this way, right? So we're going to times by x minus 1 cubed, times by x minus 1 cubed, times by x minus 1 cubed, times by x minus 1 cubed. And let's write down the new information we have in each section. My x's divide out. So don't I have an a times an x minus 1 to the third power? Then I have one of the x minus 1's divide out, guys. So I have a plus and then a bx still, don't I? X cubed over x to the x minus 1 cubed over x minus 1 to the first is, okay, good. Then we have a plus cx, and then cubed divided by 2, x minus 1 to the first, right? And then we have a plus dx, because my cubes divide out. And in the end, that needs to equal x squared plus 1, which we're leaving for now. So now your next step is to distribute. Be very careful when multiplying out a times x minus 1 times x minus 1 times x minus 1. So what I would do is I would multiply these two out together. Now I'm going to jump steps, so focus with me here. X times x is x squared, yeah? Minus x minus x. Minus 2x, and then we have a plus 1, right? Then we're going to times that to x minus 1. Now, we would distribute, right? And combine like terms. Can I just tell you what that answer is so that we can, for time saving? So we're going to have an a, then once I've done all that and combined like terms, I'm going to have this. X cubed minus 3x squared plus 3x minus 1. So now I'm going to distribute my a in. So that's ax cubed minus 3ax squared plus 3ax minus a. Now I've distributed my a in. Alright, I'm going to change colors because it's kind of hard to keep track of everything. We just did a. Now let's do b. Now make sure you don't distribute bx in, guys. Think. Bx cannot be distributed in, right? Because then you'd be squaring that. So we have bx, that's a plus sign, and then we have an x minus 1 times x minus 1. So I would distribute these two together, which is x squared minus 2x plus 1. Now distribute in bx. So that would be plus, okay, good, and then we have minus 2bx squared. You got to be very precise. If you won't accidentally write minus 2bx, the rest of your problem is going to be wrong, clear to the end. And you're not going to know where. And you're going to have to start over. And then we have plus bx, okay. Changing colors. Cx times x is cx squared. Cx times negative 1, negative cx. And then we have a dx. And then that needs to equal, in the end, x squared plus 1. Okay, reorder. Start reordering. Put all x cubes by each other. Put all x squareds by each other, x's and constants by each other. And you do that. Don't wait for me because that's going to take you a lot shorter to just do that on your own. Yeah. Yeah. Right here? Yeah, we're just multiplying it over to the other side. Okay. Right. Which one? Oh, right here. Good catch.
Couldn't you like negative x squared times that?
Yeah, I mean you could, but I just find that just as easy. So yes, you could factor out a negative if you want. Good catch, because that would have been so bad. That would have, see right there, that would have been so bad. Okay. All right. Okay, so guys, we want it to equal what? X squared minus 1? What was it? The beginning. X squared plus 1. X squared plus 1, right? So isn't that technically, like we're looking for a cube, so that's 0x cubed plus 1x squared, right? Plus 0x's plus 1. So 0x cubed plus 1x squared plus 0x's plus 1. Line up what you need to line up, set up your truth statement. 0 must equal a plus b. Do you agree?
So it means that a equals like everything so that means the section
Was 0. Yes. Okay, so then my next true statement, my x squareds line up, so this must line up with that. So negative 3a minus 2b plus c needs to equal 1. It looks like x's line up, so 0's that. So we have 3a plus b minus c plus d needs to equal 0. And then my final truth statement is my constant equals my constant, so negative a equals 1. There's my system of equations. Let's start solving that bad boy. Okay, well, the nice thing is we know a right away. Then we're going to know b. It's going to be pretty quick. Even though it looks big, it's pretty dang quick. Because what's a? A is negative 1. Okay, true. Then let's go find b. So you'd say negative 1 plus b equals 0. So b must equal 1, right? A is negative 1, b is 1. Okay, let's go plug that in to find c now. Negative 3 times a, so that's negative 3 times negative 1, minus 2 times b, so minus 2 times 1, plus c needs to equal 1. So that's 3 minus 2 plus c equals 1. 1 plus c equals 1, therefore c equals 0. And now I can find b. So 3 times a, so a was negative 1, 3 times negative 1 plus b, b was 1, minus 0 plus d equals 0. I'm plugging it in right here. Negative 3 plus 1 minus 0 plus d equals 0. So isn't that negative 2 plus d equals 0? So d equals 2. So remember those things. So my final answer is a was negative 1, wasn't it? Yes. So we have negative 1 over x, plus sign. B was 1. So we have 1 over x minus 1. Then we have a plus. Now the next one is 0 over x minus 1 squared. You don't write that one. 0 divided by anything is 0. So that's not in our answer. Then we have plus. D was 2. 2 over x minus 1 cubed. So your final answer, negative 1 over x, plus 1 over x minus 1, plus 2 over x minus 1 cubed. Woo! It's good stuff. I do like it. It's so fun. All right. All right. Okay. All right, let's talk about case number 3. Now I'm going to point something out to you. So everybody just look, I'm having you make notes. If you can't split it up the first part right, if you can't remember the rules, you're not going to be able to do it right. So, come on, computer. I'm just going to ask you, we're not going to actually do the partial fraction decomposition. Let's read the instructions. It says, how would we start our partial fraction decomposition? That one doesn't say to actually do it, but how would you start it? Like, how would you split it up? Let's see if we can practice splitting it up. Tell me the correct way to split this up, everybody. A over x plus b over... Does everybody see why they did that? Have multiplicity of 2. Okay, good. Plus c over x minus 1 plus d. Okay, good. Yep, over. Okay. Q. Good. Yes. We had x squared, so we're just splitting it up. So you always, if it has multiple multiplicity, you have to start with 1 and count up, just like we did here. See how it has multiplicity of 3? We started 1 counting up to 3. This has multiplicity of 2, 1 counting up to 2.
We need all those students going to the genius party to come to the
Now they wouldn't ask you to do partial fraction decomposition of this. They would ask you though if you could split it up, right? That's a valid question. They wouldn't have you do one that big. The actual full solution there. All right, let's do, okay. Now I just need to point something out. This is super important. Everybody focus. This is so important to see the difference between these three. All right, so with this one, this is different than this, which is different than this. Splitting them up is all different. So everybody right here, you say, well, this is a linear factor of degree 2, so that's linear with multiplicity of 2. So our splitting it up would be a over x minus 1 to the first plus b over x minus 1 squared. Yeah? Okay, let's look at splitting this one up. This is a quadratic that factors. Agree? Yeah. So this is actually 1 over x plus 1, x minus 1. Yeah? So our decomposition would just be a over x plus 1 plus b over x minus 1. They didn't have multiplicity of 2, right? Now this different. 1 over x squared plus 1, this is a quadratic that does not factor. You have to split this one, you have to write this one differently. That's case number 3. So case number 3 is what we're learning now, how we would write this one. It's not the same as this, because guys, that's not a multiplicity of 2, is it? It's just a quadratic. Okay, so here's case number 3. Write in what case number 3 is for yourself. Case number 3, when your denominator has quadratics that do not factor, we have to split it up as such. So we're going to go through and find the partial fraction decomposition. So the first thing I'm going to teach you is just kind of how you split up when you have a quadratic that does not factor. Okay, so we obviously have just our x, which is all good, same as the other stuff we've done. There's just x to the first, so we would have an a over x plus, now this quadratic that doesn't factor, it only has like x squared plus 4 does not factor, right? If it was x squared minus 4, different factor. So we can't split this up, right? There's an x squared plus 4 period. Now here's the thing though. We have to write the numerator as a linear factor. So what would be after a, b? So this would be bx plus c. So if it's a quadratic that doesn't factor, you have to write the top as a linear factor, bx plus c. So that is the splitting apart of this. Yeah, so now it's equal to that. It's equal to 2x squared minus x plus 4 over x times x squared plus 4. This one actually solves really quickly and nicely and easily. So what's our next step? But does that make sense of how we split that up, everybody? Yes. Yeah, but yes. Unless, you know, what if it would have just started? It would have been ax plus b. You know what I mean? You'll just go down the line. But yes, it'll always just be linear like that. Okay, so now we would times up by our denominator here, wouldn't we? So we're going to have a times x squared plus 4, bx plus c times x squared plus 4, and then we know it's gone out of this side. Okay, here we go. X's divide out, so we have an a times an x squared plus 4 in our first piece here. Now, don't my x squared plus 4's divide out here? So we have parentheses bx plus c times x. And that needs to equal in the end 2x squared minus x plus 4. So now we would distribute just like normal. The math is no different at this point. ax squared plus 4a. Now distribute our x in, so plus bx squared plus cx. That needs to equal 2x squared minus x plus 4. Reorder it, just like before. Nothing's changed now, nothing is different. Factor out what's in common. Nothing's in common, nothing's in common. Okay, let's line things up. I'm just going to point so I don't have to rewrite it. What's in front of x squared? 2. So isn't the a plus b equal to 2? What's in front of x? C. What's in front of x here? So c must equal -1. Easy. Or a is my constant equals 4. So 4a equals 4. Now the solving's way straightforward here because we already know what c is. C is equal to -1, circle. A must be 1. And then plug in 1 here. So 1 plus b equals 2. Therefore b must equal 1. And then all we have to do is go to our answer, which was this. This is our answer, but we got to now fill in what our a, b, and c are. So our a was 1, so we should have 1 over x, plus my b is 1, so that's 1x, with 1x, and then plus c. So then 1x plus -1, so I'm going to write -1. All over x squared plus 4. Woo woo! You got to remember all 3 different pieces. All 3 different cases, I guess I should say. Hey. Ay, 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 ay. Let's make sure we can split these 2 up. Wow. Wow, what a long lesson. Okay. I would write these down for yourself because you don't want to get home and not be able to split it up correct. After that, I have confidence you could probably solve it correctly, honestly. So I want you to write these 2 down for yourself because this one's going to have a mixture of all of the above. Let me go like this. I'm going to add in like a... I'm going to add in something here. Start writing these down for yourself. We're not going to actually do the partial fraction decomposition. We're going to split it up because that's the hardest part, I feel like, for people. All right. So if I said to you, find the partial fraction decomposition, you'd have to first write out a true statement split up correctly based on the 3 cases of the denominator. So notice, well, I'm going to let you write before I say notice anything. And then I don't want to... Okay, let's see how we would at least just start splitting this up. Okay, first of all, isn't this a quadratic that doesn't factor? Quadratic that doesn't factor, isn't that the linear on top? Okay, so let's write it. We would have a ax plus b over 2x squared plus 1, because that can't be split up. That's got to be all one term, but we have to have ax plus b. Now we have a quadratic that doesn't factor again, don't we? So we have plus, good, cx plus d, we got to keep going down the line here of our alphabet, over x squared plus 1, because that can't be split apart. Then we have plus e over x minus 3. Very good. And that would equal that. We would do our timesing up our denominator and we solve from there. Very, very good. Okay, this one has a mixture of all 3 cases in it. All right, so let's look here. Any questions on this first one, first of all? Okay. All right, this one, let's rewrite it. Quadratic that has, well, it's a linear factor of multiplicity of 2. So, okay, good. A over x plus 1 first, plus b over x plus 1 squared. Okay, good. Now we've taken care of that. Quadratic that doesn't factor, but it's also raised to the 3rd power. Okay? But still, will kind of work the same way. So, plus cx, oh, it's not cd, sorry, cx, sorry, yes, cx, then what? Cx plus d over, yes, good. So the first, we got to count up on this one. Now, plus, yep, ex plus f over, counting up, x squared minus 2 squared, counting up, gx plus h over x squared minus 2 cubed, and hallelujah, we see it gives you hi, plus I over, good. Yes. Yeah, they might ask you to write this out, split this up. Yes. Oh, I didn't mean to put the same factor. Crap. Remember, I just added this in. Sorry. This shouldn't be the same factor as that, because you're right. That would have been bad news. Sorry. That would have been, let's pretend this was an x minus 1. I'm so glad you said that, because the video might have been confused. Okay, awesome. All right. Do you guys want another example like this, or do you guys feel like you're good? You're sure? Okay. Do you guys want to make? Okay, wait. I just want to make sure. How would you split this one up? Just tell me, and then we're done. But we gotta look at this one. No, really, you gotta see this. Wait, does this factor? Yes. It does? No. Yes or no? No. Okay, it doesn't. 1 multiplies b1 and adds up to b1. Okay, so a over x minus 1 plus b over plus bx plus f plus ij, is that what's next? Okay, I trust you now. All right, that's the end of the lesson. That's fun. All right.